The astronomical term nebula has come down through the centuries as the name for permanent, cloudy patches in the sky that are beyond the limits of the solar system. The interpretation of these objects has frequently changed, but the name has persisted. Edwin Hubble.
So in these four images, to our 21st century eyes, they all look, even though they all look very similar, we clearly know that the first two images here, we see these in magazines all the time, these wonderful Hubble Space Telescope images. You can find them in several magazines, in any magazine rack. And the first two are exploded stars that have gas shells around them, and the second two are galaxies. And to our eyes, we see that immediately. We can instantly see that. We know the difference between what a galaxy looks like and what these are called planetary nebulae, what these are. But at the time that Hubble was working, the assumption was they were all called nebulae. And they were all thought to be star-forming regions. And in fact, stars are being born in all these regions, but the two on the left, the planetary nebulae, are right nearby, and the two on the right are very far away, and that's what Hubble was able to tell us. But there was a problem because the term nebulae applied to everything. And so Hubble was struggling about what do we call these things. And it really didn't settle down until the 1940s. So here we have an old paradigm. And this is represented by Byron's, Byron has, his posters are wonderful. His portrayal of 7 galaxy-like super universes scattered around the central universe on the left, under the old paradigm. It's a very useful image, but it's baggage, and it can be constraining baggage if you don't move beyond it. So in the new paradigm now, we have, instead of galaxy-like clusters that form a superuniverse, we really have superclusters of thousands of galaxies in motion together. So on the left, in the old paradigm, we have 7 galaxy-like structures in motion. On the right, we have these huge superclusters of thousands of galaxies in motion together. And the Urantia book refers to the Milky Way by name only 7 times, where it only referred to galaxies only 21 times. Go ahead, Mike.
Practically all of the starry realms visible to the naked eye on Urantia belong to the 7th section of the grand universe, the superuniverse of Urantia. The vast Milky Way starry system represents the central nucleus of Urantia, being largely beyond the borders of your local universe. This great aggregation of suns, dark islands of space, double stars, globular clusters, star clouds, spiral and other nebulae, together with myriads of individual planets, forms a watch-like, elongated, circular grouping of about 1/7 of the inhabited evolutionary universes.
So they're scattered throughout the Urantia book. There are 2 paradigms running. There's an old paradigm and a new paradigm. So the Revelatory Commission needs to speak to people current at that time, and they need to speak to us in subsequent generations. And the language of the Urantia book is phrased to do exactly that. And I love this paragraph. This paragraph has been a stumbling block for Urantia book readers for a very long time because it seems to suggest that the vast Milky Way starry system is equivalent to Urantia, except for the fact that they sneak in this term, spiral and other nebulae. Spiral and other nebulae are galaxies. And at the time of the appearance of the Urantia book in the 1930s, Hubble had already done his work. Something was known about the universe, but the vast majority of mankind was probably absolutely clueless about the fact that there was more than one galaxy in the universe. So that was a task. It was a huge task for the Revelatory Commission to phrase a language that could speak to both the previous generations, the current generations, and future generations at the same time. And I'm going to come to this very shortly because this paradigm shift took place in the early 1920s, but how many people really knew about it very shortly after? And here's the issue. So if the Urantia book seemed strange, if in the course of reading the Urantia book you've thought that the cosmology of the Urantia book seemed a little bit strange, things are even stranger now in astrophysics. So here's what I want to ask you. As of 1998, there was another paradigm shift that took place. And how many people in this room really have a clue as to what that major total shift in understanding was that took place in 1998. So here we are 10 years away from this last paradigm shift in 1998, and probably most people in this room would be very hard-pressed to say anything about what it was, and it completely changed everything, just as Hubble's work changed everything in the 1920s. And what was arrived at in 1998 was an understanding that the universe must be made of 73% dark energy. That was completely unexpected, that finding. And actually only 10 years prior to that was the realization that another 23% of the universe must be made of cold dark matter. So we have a dark matter and a dark energy that make up 96% of what the universe must consist of, leaving only 4% in the form of atoms. So think of the fact that everything that science knows about, everything that astronomy knows about, and geology and biology, amounts to, at best, only 4% of the universe that must be out there. How's that for chutzpah? Dark energy, by the way, and I'll just touch on this. We have this image of dark matter. And dark matter, there's been almost no progress made whatsoever in understanding what dark matter and dark energy are. The progress that's been made has been in understanding what dark matter isn't. For a long time, there was an attempt to try to see if dark matter was made up of things like dark stars and dark planets and maybe black holes and things like that. And much work has been done, and it's not there. Those are called machos, the massively compact halo objects, and they have not been found. And so what's been settled on now instead in an understanding of dark matter is called WIMPs, weakly interacting massive particles. That's what astronomy is looking for, and with the new collider that's coming online now in Switzerland, they're hoping that they might begin to discover something like that. So again, embedded within space is this enormous cloud of dark matter that holds every galaxy together. The amusing thing for us as Urantia book readers is that we've been told something of a story about other kinds of materialization that exists right here, right now. It's called Urantia, and it is gravitationally bound. It is subject to gravitation. And so it's all very amusing, because there is, the Urantia book actually suggests things that astronomy and physics are grappling with. Dark energy, on the other hand, which amounts to something even more in the universe, assumes that embedded within space, it used to be thought that space was nothing. Dark energy demands, here's the story. In 1998, it was discovered that the universe is not just expanding, that there's an accelerative component to the expansion. For there to be an acceleration in the expansion of the universe, embedded within space itself has to be a mechanism that's pushing space apart. And it's referred to in a variety of ways. Quintessence is one of the names. It's space foam. But embedded within space itself is something that is pushing space apart. The amusing thing, of course, for Urantia book readers is that in this pushing of space apart, in this accelerating expansion, I loved it when I heard about this, because as Urantia book readers, we are told that space has a 2 billion year expansion-contraction cycle. Right now, astronomy has noted that this expansion cycle has at least started 5 billion years ago, appears to have no end. Well, the Urantia book says there's a 2 billion year cycle. Well, astronomy hasn't found that one yet, but the fun thing is that the Urantia says that there is a cycle. And if there is a cycle, it means there has to be accelerative expansion and contraction, acceleration, deceleration components in a 2 billion year expansion contraction cycle. And what astronomy has found is this accelerative component. And we've already been told about that in the story of the Urantia book, that there is exactly that going on. So the Urantia book is in its story. And again, here, this wonderful pie chart is simply a story. When you can't say anything about what dark matter is or what dark energy is, it's a story. It just says that gravitationally, these things have to be there, but what they are isn't understood. Okay, we're going to move on to smaller scale now. And the smaller scale is moving down to the idea of what is a minor sector. How do we see galaxies as minor sectors? So on page 168.
The rotational center of your minor sector is situated far away in the enormous and dense star cloud of Sagittarius, around which your local universe and its associated creations all move and from opposite sides of the vast Sagittarius subgalactic system, you may observe two great streams of star clouds emerging in stupendous stellar coils.
Now this is something that, again, has probably thrown careful readers of the Urantia book for a long time. Sagittarius, in the night sky, in the summertime, in the south, is this wonderful splotch of the Milky Way. It's perfectly visible. You can't miss it. It is really gorgeous. And the Urantia book is saying that the center of our minor sector is located in this direction. Well, it turns out that the center of the Milky Way is exactly in that direction. When you look into the Sagittarius center, we are looking exactly towards the middle of the Milky Way. It's commonly understood. There's nothing confusing about that, whatever. But what they're going on to say here is that there are two streams of stellar coils emerging from it. And so here's an example of a galaxy with two huge streams of stellar coils. In fact, we started this entire presentation with an image of M51, which is again an example of a barred spiral galaxy with two streams of stellar coils. So there's a nice parallel here. But here's the funny thing. This was not validatable until 2008. As of 2008, we now have data showing that our Milky Way consists of two huge streams of stellar coils like this. The previous image is this one. And again, the great thing about this is the artist who produced these images is the same artist. And in one case, he has produced the traditional image that was relevant up until 2008, and now we have this wonderful image in 2008. And the previous image was multitudinous arms that the Urantia book, the Milky Way seemed to be constructed of. And that, in all astronomy books up until 2008, that's what you would have seen as the representation of the Milky Way, and it's no longer accepted. And here's the problem. You see, again, we're back to the same problem. When you want to see arms, when you want to document arms in our galaxy, how do you do it? Because what you have to do is you have to look out through the stars that make up the band of the Milky Way. It's really hard to do. It is very hard to do. But to document what's going on out there, you have to do it. Now, it turns out the Spitzer Space Telescope is a new scope. It's an infrared scope, and it's able to penetrate to some degree what's going on out through the vast billions of stars that comprise the Milky Way. Remember, we can, in Deep Space Explorer, we're easily able to look out into the north and south, above and below the Milky Way, and document everything that's out there. But when you try to look through the Milky Way, you've got a problem. And the Spitzer Space Telescope was able to do that, and in the course of looking out there, it tossed out the idea of multitudinous arms and said, guess what, we're a barred spiral. And it does fit this Urantia book image. So insofar as Erwin Ginsberg and other people have been suggesting to us for a long time that the Milky Way is a minor sector, that our minor sector of ENSA is the Milky Way. This really, as of 2008, pictorially stands to be